Dr. Mastroiannopoulos, distinguished speakers, distinguished guests, dear project officer from the European Commission, ladies and gentlemen. A very good morning to everyone, and thank you for joining us at the second virtual international workshop on atmospheric climate research in the Eastern Mediterranean, Middle East, and North Africa, the EMMENA region, organized today by the Excelsior Teaming Project Consortium and the Eratosthenes Center of Excellence of the Cyprus University of Technology. On behalf of the Excelsior Consortium and the Eratosthenes Center of Excellence, I would like to express a very warm welcome, and I would like to welcome you to this online today workshop that consists 22 invited talks from high caliber scientists and researchers. This workshop is a part of a series of annual workshops with participation of all national and international stakeholders of Excelsior project, addressing all the different activities of the Eratosthenes Center of Excellence, such as infrastructure, research, education, innovation through entrepreneurship. The main aim of this today workshop is to bring together atmospheric researchers and Excelsior stakeholders concerned with the EMMENA region for identification of challenges and future projects. This is a time to join forces all together for scientific growth and improving the quality of life of our citizens. The second virtual Excelsior workshop is co-organized by a lot of organizations, but I would like to mention the National Cyprus Remote Sensing Society. I would like to express my gratitude and appreciation to the European Commission and the Government of Cyprus for funding the Excelsior Horizon 2020 teaming project. I would like to express my thanks to our project officer at the European Commission, Antonio Venchio, the Chief Scientist of the Republic of Cyprus, and the Deputy Ministry of Research, Innovation and Digital Policy for their great support. I would like to take this opportunity to express my sincere thanks to all the speakers for their kind acceptance to participate today in our workshop. And finally, I would like to express my thanks to the Excelsior partners and especially to Tropos for their great support. We hope that you will find the workshop both enjoyable and valuable. In closing, I wish everyone a successful and fruitful workshop. Thank you very much.
Thank you, Professor Hadjimitsis. Now we are pleased to welcome the Chief Scientist for Research and Innovation of the Republic of Cyprus for a short welcome note. Dr. Nicholas Mastroiannopoulos, as soon as you're ready.
Thank you very much. Always good to see my dear good friend Iohandos and good friends from the Excelsior and Eratosthenes. Good morning to everyone, distinguished guests, ladies and gentlemen. It is with great pleasure that I welcome you also today to this second virtual international workshop of the Excelsior project with a view to tackle the atmospheric and climate research in the Eastern Mediterranean, Middle East, and North Africa region. It truly is an honor to be here, and I would like to congratulate organizers of these events, the Excelsior project, the Eratosthenes Center of Excellence for their dedication, restlessness, efforts to boost research and innovation in our country, organizing such initiatives with the participation and representatives of pioneering the world-leading organizations from abroad, such as NASA and the European Space Agency, as well as prestigious academic and research institution, is vital in order to discuss the latest developments in topics that can address a wide range of challenges and to facilitate the exchange of knowledge and experience, which is a major issue. The field of space-based technologies was once considered to be too advanced for a small country like Cyprus, a possibility that not many will have dared to consider 20 years ago. To this end, we are particularly proud of the establishment of Eratosthenes and the Excelsior project, being in fact one of the most ambitious in the research and innovation history of Cyprus, aiming to establish our country in the sector of space technology. Focusing on the area of Earth observation, space applications, and geospatial information and analysis, Eratosthenes aspires to become a fully functional innovation hub and a research excellence center in the EMMENA region, while it's creating an ecosystem where state-of-the-art sensing equipment, cutting-edge research, targeted education services, and entrepreneurship come together. In a rapidly evolving world where humanity is facing increasing challenges such as the global spread of infectious diseases and of course climate change, which possesses a large-scale hazard to human health and has both a direct and indirect impact on species and ecosystem, is now even more essential than ever to embrace results-driven creativity. This is the reason why fueling cutting-edge ideas across all levels of education, society, and industry, facilitating research, innovation, and technology, along with cultivating green consciousness, stands as a top priority for us. To this end, the direction of the Cypriot government is clear. Formulate a new sustainable growth model which fosters research and innovation and technology, accelerating the transition to a green economy and increases efficiency through digitalization, being capable of expanding the productive base of the economy. We have to move forward, and this is the only way to do so. Having this in mind, the Research and Innovation Foundation, as you already know, launched the bridge funding programs in April with a total budget of 15 million, aiming to provide incentives for collaborations between the private and the publicly funded academic and research organizations, while strengthening the competitiveness of the entire ecosystem and increasing the critical mass of research activity in Cyprus. We lack in the collaborations between the private and the public sector, and this is our also our top within our top priorities. Big opportunities also arise from the Europeans' new and most ambitious funding program for research and innovation, Horizon Europe. The program opens the way for real actions and progress, assembling the world's best minds to work together and deliver revolutionary smart solutions to a key issues of our times. With a total budget of 95.5 billion, Horizon Europe looks ahead in making the continent a strong force in a digital age that respects and protects our planet. For us, through the different capacities under the umbrella of the Cyprus National Research and Innovation Governance System, but also for me personally, synergies along with the developments of a culture of creativity and innovation are essentially the driving force behind the creation of a productive R&I environment, which will strengthen the local ecosystem and lead to the development of and commercialization of value-added innovative products and services. An ecosystem that is fit for the future and efficient, adding value horizontally across all sectors of the economy. Acknowledging the high importance of broadening the academia industry cooperation networks, the Research and Innovation Foundation is setting up the Knowledge Transfer Office and has formed a collaboration with knowledge transfer consultant Tom Hogady. As you already know, is under consultation with all the institutions and universities in Cyprus and innovative businesses in order to target and convey streaming scientific and technological research to the market and thus the wider society. Dear members of the Eratosthenes, I would like to congratulate you once again and for all your efforts and support and aspirations to transform Cyprus into a national and regional hub for Earth surveillance and space-based monitoring to the environment. I'm confident that the discussions that will follow will prove to be thought-provoking and beneficial to our joint efforts for a better future driven by research, scientific excellence, and innovation. Thank you very much, and I'm always on your side.
Thank you, Dr. Mastroiannopoulos. Next up, I call Kyriakos Themistokleous. I give the floor to Dr. Kyriakos Themistokleous for a brief overview of the Excelsior project. Is Dr. Themistokleous ready for his overview? Or we can proceed to Professor Albert Ansman's introduction to the Eratosthenes Center of Excellence. Please give us a few, just a few minutes.
Should I wait?
I think we can go ahead and go ahead with Professor Ansman's presentation, introduction to the topic, the Eratosthenes Center of Excellence, a future hub of atmospheric science in the EMMENA region.
Okay, you will see my screen here. And Johannes Bühl, he organized this workshop. He asked me to give a small note on the historical development and our cooperation with Cyprus, with COT. And I will do that. And maybe I start with this overview. So the COT got a first LiDAR in 2012, 2011. And we started our cooperation already in 2012, 2013. And as you can see by the arrows, so we...
Albert, we can't see your screen.
You can't see the screen.
I think you have to share it somehow.
But I did it already. Maybe I go back.
You haven't shared yet the screen yet.
Is it okay?
No, you should click the green button on the bottom of the...
Wait a minute. Wait. This one? Is that it?
Yes, now we see your screen.
Okay, great.
Great.
Okay, so maybe I go, so this was the entrance. So I was asked to give a small note on the historical development, and I did that here in this view graph. Sorry, a bit confused. And as you can see, the arrows got bigger and bigger. And we already had the dream in 2015 when we had a big European program, Bacchus, to end up with really something like a center of excellence for atmospheric studies in Cyprus, and not only at COT, but together with the Cyprus Institute. So as you can see already on the right side, we had a dream already 5 to 7 years ago to end up with such a big center. And I was hoping that Kyriakos gives an introduction into Excelsior, but we will have the opportunity later on to see much more of that. And everybody knows who is now here in this workshops that the Eastern Mediterranean, that includes Cyprus, but also, for example, Israel, is an exciting place for atmospheric science because you have a lot of different aerosols. You get a lot of cloud formation, precipitation formation in very different aerosols. So you can really end up with a clear picture on the aerosol impact on atmospheric processes. And that means also in the framework of climate change. So that is a real nice area in Europe to do a lot of atmospheric science. And as I mentioned, we had a big program, research-based, and it was coordinated by ETH in Zurich, Switzerland. And that was 5 years, and that really speeded up all our cooperation with the institutions in Cyprus. And for example, we had a first big campaign in 2015, and you see on the map Limassol with a LiDAR station. We had another LiDAR station at the Cyprus Institute in Nicosia, and we had a field site in the Troodos Mountains. And so we had UAVs, we had in situ observations, we had remote sensing, we had clouds, we had aerosols, everything. So it was really fantastic. And this is our laser beam 2015 above the institute in Nicosia of the Cyprus Institute. And this was our small field site to that time, a Doppler LiDAR, a photometer, and an aerosol cloud LiDAR. This was a starting point. And 1 year later, we had a big campaign in the Troodos Mountains. More than 50 scientists participated from different groups, from Bacchus, from Inuit, from very different agencies. And again, very nice conditions. We could compare UAV profile observations of dust, mass concentration, and even INP. And all this is really nice. And I have to say, I was surprised to see that all the efforts in Cyprus, even they have an airport for UAVs, and it's amazing to see all this. I was really happy to see it. And from Central Europe, Cyprus is a small island, and I really cannot distinguish between the Cyprus Institute and the COT. So for me, both institutes are very important to speed up atmospheric science in the Eastern Mediterranean. Afterwards, we decided to bring our big package of remote sensing to Cyprus for more than 1 year, 18 months of measurements from October 2016 to March 2018. And this is a rather modern CloudNet station with cloud radar, microwave radiometer, different Doppler and aerosol lidars, and even a distrometer to get the rain size distribution. And that is a really very modern station, and it fits very well to Actris as a whole. And Actris, a big infrastructure project, we will hear about that later on, is really missing a point in the eastern part of the Mediterranean. So we will build up the same station again in the framework of Excelsior. So there will be a very powerful remote sensing station in 2022, 2023 at Cyprus in Limassol. And we had even a big campaign within this SciCare campaign, in this 18 months campaign in April 2017, where we brought together aircraft observations and remote sensing, and again, because of the exciting area of Cyprus. And we have to continue with this because it's always necessary to have validation experiments between in situ observations, aircraft, UAVs, and remote sensing. So I think Cyprus is now, meanwhile, very well known in Europe, and it's time to be a real member of Actris, what we are now doing together with the Cyprus Institute, and that makes me really happy. And this was my small note of 5 minutes, and I see the future is bright if you go towards Actris, to the Eastern Mediterranean, Middle East, Northern African region, and even with respect to ESA and NASA activities, both plan new LiDAR and radar-based missions, and they need ground truthing, and Cyprus is an ideal place for all that. So thank you very much for listening, and I wish that we will have a nice workshop today. That's it.
Thank you, Professor Ansman. Kyriakos Themistoklos is having some issues with his laptop, so we will have the presentation now, but it will be given by Professor Hadjimitsis instead. So, Professor Hadjimitsis, we are ready for the intro.
Okay, can you see my screen? Can you see my screen?
Yes.
Okay. Good morning again to everyone. Thank you very much, Alper, for your excellent presentation and for your kind contribution in the Excelsior Consortium. I will try to be short. Here is outline of my presentation. A short introduction, who we are, what is the Excelsior project, and I will give you an overview of the last 13 years activities. Who we are based in Limassol at the Cyprus University of Technology, which has been established by law in 2003 and started our educational programs in 2007. We are using the Excelsior Horizon 2020 TIMIC project to upgrade our 13 years experience in Earth observation to a center of excellence. And the name of the new entity, in which the sole member of this entity is the Cyprus University of Technology, is called Eratosthenis Center of Excellence. Cyprus University of Technology is one of the 3 state universities in the Republic of Cyprus. As I mentioned before, it was founded by law in 2003, and it welcomed its first students on September 2007. The university consists of 6 faculties, including the Faculty of Engineering and Technology, 13 departments, and 1 language center, offering academic degree programs, 15 undergraduate, 15 postgraduate, and 15 doctoral. The 2018 and 2021 list of the Time Higher Education World University Rankings rank our university within the 351 to 400 and 301 to 350 best universities in the world. We are based on the Faculty of Engineering and Technology that consists 3 departments: the Department of Civil Engineering and Geomatics, Electrical Engineering and Computer Engineering and Informatics, and finally, Department of Mechanical Engineering and Material Science and Engineering. We started this journey in 2007 as a small remote sensing geoenvironment lab, and then we expand our activities not only in Earth observation, but also in geoinformatics. In 2016, we submitted the first stage proposal that has been ranked first in Europe. In 2017 and 2018, we implemented the phase 1 proposal, and on August 2018, we submitted the business plan. In November 2018, we submitted the second stage proposal, and finally, in 2019, we are successful, and on October 2019, we started the Excelsior project. Here is our premises in the center of Limassol, which are based in the Department of Civil Engineering and Geomatics. I would like to mention that in our department, we are offering 5 educational programs. 1 in Surveying Engineering and Geomatics, and MSc in Geoinformatics and Geospatial Technologies, PhD in Civil Engineering and Geomatics that are interrelated with the Excelsior project, plus Bachelor in Civil Engineering and Master in Civil Engineering and Sustainable Design. Our group consists up to now of more than 75 existing faculty members and researchers. As I mentioned before, we started out our activities in 2007, and we are proud that we have already participated in more than 85 research-funded projects with funding sources from national, European Union, and industry. We are a member of ISPRS, NIREFS, Copernicus Academy, GEO, NASA, METRIN, and other prestigious networks like Actris, Earlynet, Aeronet. And based on the business plan that we submitted 2 years ago, we are proud that we have already established our stakeholder hub that consists of more than 500 across Europe and international level. What is the Excelsior Horizon 2020 TIMIC project? The idea is to upgrade the existing low performance countries, building on partnership between leading scientific institutions in low performer countries. And the idea is to find pioneer partners in Europe in order to help our country to be upgraded in research and innovation. This was the idea of Excelsior. And as a consortium, in our capacity as experts in Earth observation and geospatial information and space applications, we are motivated from the fact that the European Commission will invest 16 billion in space building upon Galileo and Copernicus, and we see the opportunity in the fact that the Cyprus government is investing to become a full European Space Agency member. We are inspired from the fact that Earth observation has been already identified in the past by ESA experts as one of the 3 domains for potential future plan for European corporate stage project in Cyprus. And I would like to mention that we are the only Earth observation center in Cyprus. And what is the challenge and the main objective is to support to the impact of the Excelsior project, to the quality of life of our citizens, and this is the motto we support our project in Brussels. Space-based Earth observation, where 3 continents meet, facing common challenges for making cities and societies resilient to sustainable development. Here are the details of the Excelsior Horizon 2030 project. Is 15 years projects. The 7 years will be funded by the European Commission, and the last 8 years will be continue funded by the Republic of Cyprus and the Cyprus University of Technology. What is our mission? To upgrade the existing activities in remote sensing at the Cyprus University of Technology to a sustainable, viable, and autonomous center of excellence, the Eratosthenes Center of Excellence. And here is Excelsior Consortium, consists the Cyprus University of Technology as a coordinator. We have Department of Electronic Communications, Mr. Georgios Komodromos, as a partner. We have NOAA, Beyond Center of Excellence in Athens, Haris Kondoes, and we have 2 German partners, Tropos, Dr. Alper Rasmussen, and DLR, Mr. Gunther Schreier. This is our team before the submission. This is our team during the kickoff meeting. We make a lot of, we are involved in having close collaboration with stakeholders. This is some snapshots of the public inauguration of the Excelsior project. And here is the external advisory board. Dr. Visser Ambrosia from NASA, Marcello Maranesi, Professor Lena Halunova, Peter Zeil, Simonetta Zelli, Daniel Barro. Why we choose the consortium? We choose DLR to support our center to establish a satellite receiving station, and NOAA to provide all the expertise to establish a Copernicus node, Tropos to help our center to establish a ground-based atmospheric remote sensing station. Why Cyprus? As Dr. Alper Tasman mentioned before, we choose Cyprus because we have a unique geostrategic position, and it is the ideal place for calibration and validation purposes. And I would like to highlight also the excellent good weather conditions for remote sensing applications. And I would like to mention the area that we are concentrated, the EMMENA region. There are some needs to establish the Eratosthenes Center of Excellence in Cyprus and the EMMENA region. There is a need to establish a super site for aerosol cloud monitoring in the EMMENA region. We're identifying the business plan. We want to support using Earth observation activities in droughts and water shortage, research, rehabilitation program, disaster risk reduction, and there is a big need to establish a regional digital innovation hub for Earth observation. Our Excelsior project fully comply with the smart specialization country needs. We are based in Limassol, and we have a great support from different coastal municipalities like Municipality of Limassol, and we are planning to expand our activities in the 3 main pillars of our university master plan in the center of Limassol and in Vergaria Polemidia in Limassol. Here are some maps that we're going to establish our permanent premises on 2024. And finally, very quickly, Eratosthenes Center of Excellence, the whole structure acting as a digital innovation hub. As you can see, we have already established a board of directors, 7 members of board of directors, and here are the members. We have our colleague, Professor Agilas from CUT, 2 former ministers, Marios Dimitriadis, Vasiliki Anastasiadou, Barbara Ryan, former Secretary of GEO, Rosala Savonara from CNR, Nektarios Christoulakis from FOR, and Mr. Christos Stylianidis was the former European Commissioner. What is the vision of the new center? Is to become a world-class digital innovation hub for Earth observation and geospatial information, becoming the reference center in the Eastern Mediterranean, Middle East, and North Africa. We identify in the proposal and the business plan 5 application domains that we want to be excellence in research: access to energy, disaster risk reduction, water resources management, climate change monitoring, and bigger data analytics. Here is the structure of the digital innovation hub. And as you can see, we have 3 departments: environment and climate, the resilient society, bigger data analytics. And we have 4 horizontal functional areas: infrastructure area, research area, education area, and entrepreneurship. Based on the business plan, we are going to employ in the next 7 years more than 100 personnel, and we are planning to establish our permanent premises, 2,000 square meters, in the next 3 years in Vergaria area in Limassol. Here is our strategy based on the Digital Innovation Hub, and we identify, in order to be sustainable, some sources and funding sources, either from industry, European projects, EMMENA project, national project, and ESA projects. And what is the impact of this new center? To provide relevant information for decision-making to science, industry, and government in order to support policies, business development, improve the quality of life for all citizens, and generate economic growth. Here are the 3 main infrastructure of the new center. We are planning to establish a ground receiving station, the antenna, with the help of DLR, state-of-the-art remote sensing station with the assistance of Tropos, and Copernicus Hub with the assistance of NOM. As I mentioned before, Cyprus has a unique geostrategic position that can support Earth observation from satellites program in 3 continents. Here are some snapshots of the infrastructures. And here is a snapshot of the GPS that will be established shortly in the next few months or 1 year from now. And we are proud that from October 2020, we received the Poly-X LiDAR from Tropos as a part of the commitment to the new center, the Radosthenis Center of Excellence. And I would like to express my great thanks and appreciation to Tropos team for this. The new center acting and engage the multi-actor approach, linking actors segmented according to the geographical location, their position in their observation value chain, and they are maintained. Here are the multi-actor characteristics. We want to establish in the next few months and years a skills development center, professional training program, networking and knowledge hub, regional exploitation platform, living labs, and business incubation program. And finally, I'm going to present the quadruple helix innovation model at Excelsior. By blending industry, society, academia, and government all together, we receive a big support from more than 95 organizations, including 19 governmental departments from Cyprus and 6 ministries. We have a great support from municipality, especially municipality of Limassol, and support from other national universities. I would like to mention also the great support of the Cyprus Telecommunication Authority that committed to support the establishment of ground receiving station in their premises for the next 15 years. We receive a big support from international partners like NASA, ESA, Israel Space Agency, Airbus, Hexagon, ERSEL, Aristotelion University of Thessaloniki, National Technical University of Athens, UCL, Actris, Forth, ISPRS, Tel Aviv University, and other university in the European area and international area. Very quickly, some snapshots of our activities for the last 13 years from funded project activities within the group. We are using Earth observation for monitoring deformation from space, for flood risk assessment, water leakage detection, fire detection, agricultural application, cultural heritage, air pollution and climate changes, air quality and aerosols, maritime awareness and ship detection, land cover changes, marine spatial planning, remote sensing for asphalt pavements, promoting space education with Copernicus Academy and NASA. And for the last 2 years, we tried to establish a big infrastructure for monitoring natural hazards in Cyprus with the assistance of DLR. We are proud that with Tropos, we have a project from the national funding. It's called Sirocco, for studying the precipitation, aerosol, and clouds in a coastal area of Cyprus. This was an excellent hub that has been granted 4 years ago. We're running a project on data analytics for cultural heritage with DLR. This was a project Athena on cultural heritage in the past with DLR, Copernicus Academy, Geocradle with NOAA, and thank you very much for your attention. I would like to express my sincere thanks to all of you for your participation and support. And I would like to mention that we have an excellent collaboration with other Center of Excellence in Cyprus, and especially with EMMENA and Professor Jill Shear from Cyprus Institute. Thank you very much.
Thank you, Professor Hadjimitsis. We have a short break now, and we will return at 9:45 with the first workshop session on Excelsior partners and networks. Thank you, and see you in a few minutes. Welcome back, everyone. And we are ready to start with our first workshop session on Excelsior partners and networks. I will give the floor to the chairperson for this session, who is Dr. Rodanthi Elisabeth Mamouri.
Hello, everyone. I welcome you to the first session of the Atmospheric and Climate Research in EMMENA region workshop. Based on the agenda, there is a Q&A time slot at the end of the workshop. But if there is a remaining time at the end of this session, we can also use it for questions. Please feel free to use the Q&A tab during the presentation to set your questions. This first session is related to the Excelsior Partners atmospheric activities and networking. So the first talk will be given by Dr. Johannes Buhl, research scientist at the Leibniz Institute for Tropospheric Research in Leipzig. Dr. Buhl will talk about the ground-based remote sensing of aerosol clouds and precipitation in the EMMENA region. So Johannes, please go ahead, the floor is yours.
Thank you, Rodanthi, for this introduction. This is not the right place to start. This is the right place to start. So, I hope you can see my screen. I will give an introduction to a ground-based remote sensing of aerosol clouds and precipitation in the EMMENA region. And I'm basically representing the Tropos team that is active in Excelsior, myself, Patrick Seifert, and Albert Ansmann, of whom you heard the talk before. First, some two slides about why we consider the Eastern Mediterranean and the Mediterranean in general so important for atmospheric and climate research. You can see that in the simulations and the observations, the Mediterranean appears as a climate change dry and hot spot. And so you can see that precipitation changes, dramatic precipitation changes are as expected in a region where also a lot of people live. So but that's my introduction. I can only recommend you to look deeper into these graphics and see into these figures and see that the Eastern Mediterranean is really strongly affected by future precipitation change and climate change. So, but how do we approach the problem now? We are in a strongly polluted region in the middle of the dust belt. You can see it in these figures, and we have therefore the possibility to study aerosol clouds dynamics and precipitation interaction in very great detail, because we get dust from all sides. We get Middle East dust, we get the Saharan dust, we get mixtures of marine air masses and pollution, we get the polluted continental mass. So it's all a very interesting mix that is then mixing with the clouds. And yeah, so it's an ideal environment for aerosol cloud research, but it's also a challenging environment. Why? I can show you here. Here you can see an example case from a strong dust storm that appeared over Limassol, and in 2015, I think. And you can see that it's really that we have these kinds of extreme events really on Cyprus. So it's not only a hotspot in theory, but it's a real dust and aerosol hotspot. You can refer to this paper, Mamouri et al. In ACP 2016, where this case is described in detail. Motivated by all this complexity, we went there in 2016 and performed a larger measurement campaign called CyCare, the Cyprus clouds, aerosol, and precipitation experiment, together with our partners from a lot of science institutions and Cyprus Institute. At this time, we were stationed at Limassol at the Cyprus University of Technology with our lacrosse suite of instruments that I will explain in more detail in a minute. But this is already a setup that shows you that in the Eastern Mediterranean on Cyprus, a lot is possible. So we are motivated to do this again. But here again, to the SciCare campaign in 2016, this is the setup of lacrosse. And lacrosse, the Leipzig Aerosol and Cloud Remote Observation System, looks like this. In detail, we have a poly-XT Raman LiDAR for observation of aerosols, cloud radar for observation of clouds, Doppler LiDAR for the dynamics observations, a distrometer for the observation of precipitation, microwave radiometer gives us information about the atmospheric water content, and we have an additional solar radiation station with us. So with this suite of instruments, you can really get a complex picture, a detailed picture about a complex environment. So, and in the larger view, coming back to Excelsior project, there will be a new infrastructure at the Eratosthenes Center of Excellence at Limassol, which will consist mainly of a large antenna dish. You can see the coverage of this antenna in this red circle, and together with a copy basically of lacrosse, the so-called ground-based remote sensing station, which will have exactly the same capability. And with these instruments together, joining together satellite observations and ground-based observations, we will, the Eratosthenes Center of Excellence will be a lighthouse for the whole region for atmospheric science. So the possibilities are huge. And if you add it up on Cyprus, if you look what's already there concerning atmospheric research and what will be there in future, basically everything under the roof of Actors, you can see all these institutions, all these projects going on. And I made 3 points here because there's a lot more going on. I'm really excited to see all this happening. And this is I think, a sneak peek into the bright future of atmospheric science in Cyprus that Albert mentioned before. So, and if you look a little bit wider into the area, you see more stations popping up. On Antikythera, there is a poly-XT LiDAR station combined with a cloud radar. So we have also here a CloudNet capability and a PolyNet capability. Limassol is the same. We have a combined LiDAR radar station, and in Tel Aviv, we have an additional poly-XT LiDAR. It's still single, but this is giving us a good overview about the complex dust and cloud cases over the Eastern Mediterranean, because you see in the satellite picture, Saharan dust is pulled out of the northern Sahara, and you see together cloud formation and this dust layer. So this gives you an overview about what's possible, and I now want to really go into the scientific details. I want to go to show you in a very detailed way what we are doing with these measurements, why we need all these measurements in this detail and this complexity. So what we're interested in is I really understand how the process of ice formation and later precipitation formation works from the aerosol through the cloud to the ice crystals and to precipitation in the end. And you see here a sketch of this process. You put basically aerosol into the cloud is processing the aerosol, and in the end, ice nucleation happens and it falls out. So we have the aerosol properties that we can observe with the LiDAR on the left side, CCN, the cloud condensation nuclei, ice nucleating particles concentration, and on the other side we have the ice properties, shape, ice crystal number concentration that we can derive from combined LiDAR radar methods. And basically this is related via the cloud. And so there has to be a kind of a relationship between both of them. And we are currently researching this relationship under ambient conditions, and the Eastern Mediterranean gives us the ideal place to do this under ambient conditions. So quantitatively, what can we get out of this? We can get out a ratio between INP and ICNC, and we can do kind of a closure to close this whole process from the aerosol to the clouds. And I will show you one case about this for this closure. So you can see here dust layers in 8 kilometer height and a cloud forming within this dust layer. So we observe this cloud with the LiDAR here and the radar here. And we use, as I said, combined LiDAR radar methods to estimate what concentration of ice crystals we have here. We found out that it must be 5 to 50. And with our complex LiDAR methods to derive ice nucleating particle concentration developed by Rodanthy Mamuri and Albert Ansmann, we can estimate the number concentration of particles, which is in this case kind of estimated to about 50 per liter, maybe less. Further reading is given here, but this gives us really now a possibility to make a direct link between the aerosol and the ice that comes out. So this is something that is more or less uniquely possible on Cyprus, because this method works especially well for Saharan dust. Yeah, and to come a bit down from this basically high-end ice nucleation research to a more practical problem. This is I just introduced this this case of combined LiDAR radar observations to show you that we are now capable basically of doing long-term observations, not only of dust but also of clouds, and that we are able to combine all this. So this is the CloudNet classification mask that gives you an overview about a rain case on the 11th of March in 2017. You see the yellow is all ice. So this is the ice in the cloud that forms later the precipitation at the ground. And all this is mixed with the aerosol in the air. And you can see the aerosol observation from the poly classification mask. But poly has problems when there is rain. And of course, CloudNet has not the capability to resolve all these aerosol in detail. And this is why we went and designed a combined method and brought these two observation principles together. And now you can really see, you can get a clear picture about the precipitation and the origin of precipitation. You see that all this precipitation originates from ice clouds. And you see exactly where there was precipitation and how it now mixes into different kinds of aerosol. You see the different colors. The bright color here is a small aerosol, a medium-sized aerosol, and a large non-spherical aerosol. So, and this should just give you, this basically this list of stuff should now just give you an impression on how complex the field is and how interesting also the science is in the Eastern Mediterranean. And this is where I end. If we have some time at this point, you may ask questions now. Otherwise, there is a questions session at the end of the conference.
Thank you, Johannes, for your presentation. the time is really tight. And I cannot see any question in the Q&A. So please feel free to set your question later on if there is any other. And we will continue with the next presentation given by Dr. Sabine Wüst from a research scientist in the atmospheric sector of the remote sensing data center of the German Aerospace Center. Dr. Sabine Wüst will present remote sensing of atmospheric waves and different spatio-temporal scales and its potential in the field of medium and long-term weather forecast. So please, Dr. Wüst, the floor is yours.
Thank you. I hope you can hear me.
Yes, we can hear you and we can see your screen as well.
Perfect. Thank you. Thank you very much. So also thanks for the introduction. Yeah, I'd like to introduce to you some of the research of our group. And I will start with a very prominent example for the introduction. Currently, energy transition is a hot topic, and we use solar panels in order to convert solar energy into electric one and to make, for example, cars move. So in order to generate dynamics. And nature doesn't make this bypass. Nature uses differential heating and convection and everything in order to generate, for example, planetary waves and gravity waves. So small and large scale dynamics. And these waves, they can propagate through the atmosphere, and so they transport energy and momentum vertically through the atmosphere. So they lead to a vertical and also to a horizontal coupling in the atmosphere. So in the next minutes, I will tell you a little bit more about our research in the topic of planetary waves in the stratosphere and their possible effects on weather. I will go through some tropospheric sources of gravity waves and how the investigation of these waves might help weather forecast. And I will present you some of our own measurements. So you certainly all know that planetary waves have a large effect on our weather. They form the jet stream if we have low wave numbers, as you can see it on the, I'm just searching my cursor. As you see it on the left-hand side, we have a more zonal circulation pattern. And if we have higher wave numbers, the jet modulation is stronger and we see a more meridional circulation pattern. But planetary waves, they do not only exist in the troposphere, they also exist in the stratosphere, and through stratospheric warmings, they have large effects on the atmosphere. So on the troposphere, but also on higher atmospheric layers such as the mesosphere. Stratospheric warmings, they are due to strong planetary wave activities, which is due to resonant interaction. And these stratospheric warmings, they can lead to temperature anomalies which are persistent for some days or even some weeks in the troposphere. I've brought an example here with me from a publication of Mitchell et al. 2013. Stratospheric warmings, they are split into displacements, you can divide them, that's the better formulation, into displacements and splits. And the left column here, here are shown the results for the displacements, and on the right-hand side here are shown the results on the splits. Plotted is the temperature anomaly, and you see here the days after a stratospheric warming. And this plot is just here to show to you that stratospheric warming can cause temperature anomalies of different kinds on the Earth surface. So if we know more about this effect, we could also maybe improve the mid-range weather forecast. And planetary wave activity is supposed to change due to the changing wind regimes, which are related to the changing temperature on the Earth. So we did some very first analysis, in this case with ERA interim data, so reanalysis data. These are the temperature data. They cover 10 to 65 kilometer, and we took the time span from 1979 to 2018. And plotted here is the linear trend. So it's a very first estimate versus height. The different colors refer to the different planetary wave numbers. Red means a planetary wave with zonal wave number 1, and the dark blue is wave number 9, so zonal wave number. And shown is here mainly the hemispherically averaged temperature amplitude of planetary waves. And you see, okay, we can divide it into an absolute trend and a percentage trend. You see that planetary wave activity is changing, and it is most changing in the stratosphere. So in the troposphere, we do not see very much, we would say. Of course, ERA interim data, the higher you go, they do not become more reliable. Let's say it that way when you go higher up. But we have our own measurements in the upper mesosphere and lower thermosphere. I'll tell you a little bit more about it on the next slides, about the physics behind our measurements. But here I would like to show you this plot. This is the planetary wave activity. This time it's a little bit another proxy, but it still shows the planetary wave activity in the upper mesosphere and lower thermosphere over several years. So 87 to 2018. And you see that it varies. It varies quite much. And we use the empirical mode decomposition in order to get out the different dominating signals. And you see here that we have signals which show oscillations in the range of the QBO, in the range of ENSO, but we also see in parts the solar flux. And we have a residual, and this residual is nearly linear. And this connects this slide to the slide before. So also in this case, we have a small, but still we have a linear trend. So planetary wave activity is changing to some extent. So now I would like to tell you a little bit more about the measurements which lie behind these results I just showed to you. This is a picture taken from the ISS, so it's from an astronaut's perspective, and I'd like to draw your attention to these colorful lines here, these colorful layers. They are due to different chemical reactions, so to different molecules and atoms which are excited and which relax. And this is the so-called Airglow. And my group and me, we are focusing on hydroxyl, so on OH, which is has its center, the layer center, at about 80-70 kilometer height. And this OH molecule, this hydroxyl, it rotates, it vibrates, and when it relaxes, it emits its infrared radiation. It also emits in the visible range, but the most significant part, the strongest part, is in the infrared range. And now I hope that the video is moving. I know it's always a little bit tricky in Zoom conferences, but I hope you can see it. This is, a video of the OH Airglow layer taken with one of our ground-based systems. So we operate cameras in the infrared range, and the field of view is 60 times 60 kilometer approximately. And you see here wavy structures which are moving and which are overlaying, and you see them decaying, and these are gravity waves which are decaying, which are generated and which travel through the Airglow layer and which are decaying now and depositing probably their energy and momentum. We also operate these systems in a scanning mode, so we can cover a larger range with a good spatial resolution. And you see here on the right-hand side, the different wave structures which are interfering here. So this is the spectral range 0.9 to 1.6 micrometer, and it's integrated. We can also spectrally resolve this, or at least a part of this spectral range. 1.5 to 1.6 micrometer is what you see here. And here you have the intensity. This is measured with one of our ground-based spectrometers, which we call GRIPS, ground-based infrared P-branch spectrometer. And we use these 3 specific lines here in order to calculate temperature from them. So if they behave like this, we have a specific temperature, and if temperature changes, also the relative line heights, the relative line intensities, they will change, and you get another temperature. And this is an example of our measurements here taken at Oberpfaffenhofen. Please refer only to the upper part of this plot. Here you see the rotational temperature, which is a good estimation of the kinetic temperature. And we have here also these wavy-like structures, which are possibly due to gravity waves and also due to tides. We are not the only group who is measuring in this height range. We are engaged in the Network for the Detection of Mesospheric Change, NDMC, which you can see here. And everywhere where it is mainly green or purple, we have our own measurements, which we do in cooperation with partners. NDMC is coordinated also by DLR in cooperation with the environmental station Schneeferner Haus, just below the top of the mountain Zugspitze, and together with an Argentinian organization. And you can have a look in the daily measurements here at this web page. So why do we look, or why are we interested in gravity waves and also in infrasound? Well, natural hazards, they produce, amongst others, gravity waves and infrasound. And we'd like to learn more about natural hazards through the observation of these small-scale waves in the atmosphere. So about the activity of a source, about the characteristic of the source, about the energy change of a source. And why do we look into infrasound? Why are we interested here? Well, infrasound is moving rather fast, so at sound speed. And we have a model which is called Harper. I've not brought an animation with me because sometimes it's not working very good through video conferences. But I've brought some pictures from the animation. And when we have an infrasound source just here in the middle, this is height in kilometers, and here time is in principle running. You see that after 5 to 10 minutes, this infrasound reaches the height region we are measuring, so 87 kilometer height. And then it can propagate rather fast. It propagates vertically, and it also propagates horizontally and crosses large spatial distances. So we had the idea to learn more about storm systems, strong low pressure systems through the observation of gravity waves. And the first thing which we did was we did a campaign 10 years ago at the Balears, and we have here this very nice Medicane. And here we launched radiosondes, for example. And you see here the vertical flux of horizontal momentum of gravity waves. And this is plotted here with this dashed line. And in order to compare it, we have also plotted a calm period some days before, it's before. And you see that the vertical flux of horizontal momentum increased by approximately a factor of 5. So indeed, a storm system generates gravity waves, and they can move upwards. But we are measuring at 90 kilometer height. So the question is, do these waves, infrasound and gravity wave, do they also reach this high or this height region? And here I've brought another example. This is one of our GRIPS measurements. It was made during the same campaign. And you see here the temperature during one night. In the middle here, during this period, we have rather strong noise. So this time period is not very suited for analysis. And here you have the corresponding meteorological situation. We have a front, and this front, it is moving towards our measurement site, which was here. And yeah, during the part 1, the front was in front of our measurement site, then it passed the measurement site, and during period 3, it was behind it. And we focused now on part 1, where we had good meteorological, where we had nearly cloudless or cloudless conditions. So we had a good measurement situation. And here we saw indeed signatures in the range of long periodic infrasound and short periodic gravity waves. So this is a wavelet spectrum. You see here the time, and here are the periods, and these are the signatures I just talked about. And in order to make sure that these signatures, that they potentially come from this frontal system, we used HARPA, the ray tracing model for infrasound, which we operate, and indeed the front could be the source of these infrasound and maybe also of these gravity waves. So, and currently we are working in a project which is called WAVE, and there we focus especially on 5B systems. So these strong low pressure systems which are generated here and which travel then around the Alps towards the north and cause strong or heavy rainfall. And here we are also especially focusing on our FAME instruments, so on the cameras. Yeah, and with this slide, I would like to sum up. I introduced my presentation with the fact that atmospheric waves at different spatial temporal scales are important for atmospheric dynamics. I proceeded with some things about some facts about planetary waves. The vertical propagation of planetary waves is supposed to change due to the change in the meridional temperature gradient, which causes a change in wind, and this influences wave propagation. And through stratospheric warmings, the planetary waves in the stratosphere, they can affect the troposphere, but also the mesosphere, and so influence the weather for some days to some weeks, also in the troposphere. Gravity waves and infrasound, they are amongst others generated by natural hazards, and this is a special topic we are interested in. So we would like to learn more about the activity of a source by the observation of generated waves. And if we know more about the activity, about the changing energy content, this could be a useful information, for example, for modelers in order to improve mid-range, the weather forecast on the scales of some days. So that's the idea behind it. And we operate our own remote sensing instruments. These infrared instruments, the cameras, and also the spectrometers. And as you can see, most of our instruments, they are situated in this part. We have also some here and some here, but here is a kind of hole. And we would be very pleased. It would be really great if we could have an observation place in the Eastern Mediterranean in order to observe strong Mediterranean low pressure systems, storms, etc. So if somebody of you has the possibility or knows somebody who can be, who would be interested in cooperation here with us, I would be glad if you could give me a message. I've shown you here my email address. What we need is we are measuring inside. In front of a window, our systems are not very large. So the camera is 15 times 15 times 15 centimeter. The spectrometer is a little bit larger. We need electric current, nothing special, and an internet connection. So that's all from my side. If you have any questions, I will be happy to answer them.
Thank you very much, Dr. Wüst, for this interesting presentation, and also that you highlight this gap of observation in the Eastern Mediterranean. So this is a big field for further discussion and collaboration. So unfortunately, we're running out of time. We don't have yet some questions in the chat. So we will continue with Dr. Haris Kontoes from Research Director at the Institute for Astronomy, Astrophysics, Space Applications and Remote Sensing of the National Observatory of Athens. Dr. Kontoes will present about the big Earth observation data towards sector resilience, and he will give an overview about the EuroGeo E-Shape project. And okay, Harry. Okay.
Hello, good morning, Rodanthi. Thank you very much for the introduction. Good morning, everybody. I'm Haris Kontoes. I'm the Research Director of the Beyond Center of Excellence of the National Observatory of Athens. I'm privileged today to speak on behalf of the E-Shape project, which is running in the framework of the EuroGeo initiative. I have collected some very specific use cases, pilot studies that we run in the framework of the EuroGeo project, which are relating in the integration and assimilation of big Earth observation data towards rendering the economic sectors resilient to natural disasters. As is EuroGeo is a geo action actually, and the E-Shape project is a geo action. It builds up on the triptych of geo, advocate, engage, and deliver. So we advocate and we start from this analytic and thorough inventories of existing skills capacities at the European Union level, scientific capacity, state-of-the-art, existing innovation, data sets. But at the same time, we analyze the existing priorities, needs, and gaps to be filled in the domain of disaster resilience. We engage a big community of stakeholders across the entire value-adding chain, therefore starting from the single user, the single citizen, but also the farmer, the association, the insurance company. At the same time, we engage the scientific community, the research community of Europe, as well as decision makers and service providers and the data providers. And this is very important because, as I mentioned, we do have three big Earth observation data and other in situ data. And we deliver high-level digital services at a very good TRL level, technology readiness level. So whatever we deliver in the EuroGeo E-Shape project, because it is an innovation action, it is a type of service of high TRL of 7 to 8, or in certain cases 9, that it is a fully operational service so as to support decision makers and sectors to become resilient to the natural disasters. So we address priorities of the disaster societal benefit area and very specific targets. And this was the core for funding the E-Shape project, that we had to conclude very early which are the specific targets of specific sustainable development goals to be met. And these are several sustainable development goals and targets that are addressed through the EuroGeo E-Shape project. Including Sustainable Development Goal 3, good health and well-being, 11, sustainable cities and communities, and Sustainable Development Goal 13, climate action. What we do? We provide innovative products, and we attempt to create resilient economy drivers. So we want to secure the business continuity in the domains of agriculture, transport, critical infrastructure, energy, and facilities domain. I summarize here a few of the pilot activities that we are running today in the framework of the project. The pilot activity 1 of Showcase 6, which is the assimilation and the integration actually of big Earth observation data for the detection, discrimination, and assessment of the 4D distribution of volcanic ash over the European territories. This is a very important service, as it has been actually testified by the involved end user communities. There are many co-designers and end users asking for this type of service. Just to mention a few: the air traffic managers, the air traffic controllers, the civil aviation sector, and the business. And in order to deliver this service in real time, It is used a lot of data from in situ networks such as Actrice and EarlyNet. A lot of satellite data from Meteosat second generation in real time. I mean, as long as the data are received, they are ingested into this processing, into this processing chain. AVHRR data, MODIS data, Sentinel 5P data. And also data from volcanic observatories, including LiDAR data, radar data, and cameras. All this is for having an enhanced distribution like you see on this slide. And this is the FlexPar WRF model, which is run on the premises of the National Observatory of Athens as part of the specific service, which is providing in real time the SO2 mass concentration over Europe. And what you see here is the example of the recent eruption of the Etna volcano in the period of 31st of May to 3rd of June 2019. This is a continuous service. This is a continuous observation. It is already a system that it is plugged into the different in situ and in situ data networks, but also satellite and Copernicus hubs and Copernicus core service, so as to be able to provide this enhanced picture of the distribution of volcanic ash over the European territories for the control of the aviation business. The pilot 2 of the Showcase 6 is targeting into urban environment, and here the emphasis is to have an enhanced hydrometeorological forecasting. As you know, I mean, to have a hydrometeorological forecasting of high quality and in real time is very important to anticipate and take appropriate mitigation measures in regard to the incoming big storms and other natural hazards. And I mean, just to give you an example of what we do here is that we integrate a lot of different types of data. And this is the concept behind the EC of the ESAFE, that we integrate Sentinel data together with citizen data, with weather observatories, weather stations, etc., so as to cover the entire Europe and to have better forecasts of the expected extreme weather events. If you see here the example, you see Italy here in the middle, which is nicely covered by meteorological radars. However, there is part of Italy, which is Sicily, which is not at all covered. And in this specific case, when we forecasted for one night and we sent to the Civil Protection Authority this information about the expected storm, as it was produced by the usual forecasting system, that had a big problem because it was not forecasted in the exact storm that had this image at that night. And of course, this was possible to forecast and to reach at that level of information after we have integrated Sentinel 5P data and other in situ information. And this is the real value of this pilot activity, that it is provided today continuously into the Civil Protection Authority of Italy and other civil protection authorities all over Europe. In the following, and I'm emphasizing more on the agriculture sector because we do believe that having a resilient and sustainable production is very important for the food security and also for the local economy. And in the framework of the ESAFE project, actually we have generated and delivered to the end user community several types of services. I mean, just to mention a few, the so-called adverse selection tool, as you see here, or the underwriting tool. This service actually is now transferable to any place of Europe, and it is now applicable for different type of crops. What we do here is that we examine every specific parcel belonging to a farmer. For the last 40 years, we do a risk analysis for the specific parcel about the extreme weather events, the climatic conditions, and the weather conditions that have occurred and reported for these very small specific areas, so that we are able today to provide information to the farmer and to the association of farmers and to the insurance companies, actually, what is the expected hazard and risk because of the incoming extreme weather events, heat waves, heavy precipitation, drought conditions, etc., which may affect significantly the crop which is planned to be planted into this specific parcel. Other services which are more real-time services, the so-called damage assessment service. This is ingesting continuously satellite data so as to be able to derive every day the level of damage in case of an extreme weather event that has occurred in the area, that the parcel and the extent the parcel has been impacted by this natural disaster. And last but not least, we have other type of services which are forecasting in shorter term and longer term the expected weather and providing early warning to the farmers and the association of farmers about what they should expect in terms of extreme weather, which may impact their production in the next days. And of course, because these are services which are delivered for the benefit of the users and the farmers and the insurance companies and the decision makers and civil protection organizations, we have developed user-friendly platforms like the one you see here. All this is available through the SABE web platform. So if you visit the SABE, you will see links to many different platforms that are providing such type of services to the end user community. And these actually services, what you see here, actually you see the different parcels, the parcels which are owned by farmers who are described as customers of the insurance company. And if the farmer visits its own parcel here or there or whatever this is located, can identify by placing on top of the parcel what is the expected risk, what is the expected hazard in terms of flood, high temperature, heat waves, drought, etc. So that the farmer can know the history of his parcel before he's planting the crop. And of course, the history in terms of how prone it is to the destruction of the crop for the specific crop, because not all the crops have the same sensibility into the different weather conditions. Or this platform, for example, which is also providing to the farmer day by day the information about the level and the extent of the damage inside his parcel of the recently occurred event. This is an information which is provided, I mean, on a 10-day basis. Anytime a new satellite Sentinel-2 image, it is ingested into the system. Of course, all these are problems that have some common characteristics. These are solutions which, first of all, are large-scale applications. So we start from the single parcel, but because we are dealing with big data, we integrate at the regional, local, national level. So this is why we consider them as being large-scale applications. Of course, the common characteristic is that all these applications are characterized by exhaustiveness. Exhaustiveness in the monitoring and the mapping of crops. And we want to have all this mapping in the very high thematic accuracy, and this has been already achieved by the machine learning classification algorithm that we are using at a very large scale. And all the solutions are open and reusable and transferable so as to be applicable from place to place, so as to cover as many regions over Europe. In all cases, we have to deal with the big data management. Just to give you an idea, more than 10 terabytes of data of Earth observation data, satellite data, and feature spaces with dimension of more than 300. More than 200 gigabytes of feature spaces are processed at once into our classification algorithms on a weekly basis. And of course, in order to do so, we have to go from conventional computer systems to the distributed computational environment to run this type of applications. All these algorithms, they have a low dependence on ground truth information. Ground truth information is difficult to get access, it is costly. And in most of the cases, we experience scarce of ground truth data. So in all the cases, we are augmenting the data set, we are creating data sets, training data sets so as to train the algorithms to the extent that it is necessary for getting the high level of classification accuracy. And the algorithms, they present high generalization. All these machine learning techniques, we try to be as generic as possible so as to be transferable from area to area. And of course, HPDA could not be omitted because, I mean, to be able to process this data on a weekly basis, such a big data, we have to do it, and we process that on an HPDA technology using Apache Hadoop technologies and using parallel nodes, many parallel nodes, so as to decrease, as you can see here in this graph, the time needed for the processing of the data by the increase of the nodes that are used in parallel for the processing. The solutions that I presented to you before, they are based on some very common projects at the same time, not only common characteristics and technical solutions, but basic products, which are large-scale products, which are also generated by the use of the Earth observation data. So in every area, which is under consideration today, we do a month mapping of each parcel in regard to the crop conditions. So we know month by month, from the beginning of the crop season until the end of the crop season, what is the crop, sorry, which is inside each parcel. And you see here month by month what is the crop classification. This is one specific crop over a very big area of interest, and of course this is done for all the other crops that are used. Also on a 10-day basis, and also at the parcel level, we have an assessment, as you see here on this slide here, how it is changing from month to month or 10 day to 10 day, every 10 days. What is the status of the phenology of the crop from the beginning of the crop period up to the end of the cropping period. So I mean, you can have now a clear idea at the level of the farmer, and the farmer is enabled to know what is the level of the phenology of the crop inside his parcel. And of course, this is very important because in the same time frame, every 10 days to 1 month maximum, we have an early assessment of the expected yield for each farmer. Of course, all this, again, it is distributed to the end user, to the farmers and to the insurance companies through specific web platforms that have been developed for the benefit of these end users and co-designers. And so the user is logging into the system, is visiting the parcel he owns, and he can get for the specific parcel or parcels he owns the status of the phenology and the assessment of the yield at the level of the parcel. And of course, this information and all the services that we are providing in ESAPE are not only web-based services, but also services which are sent out to and shared with the users at their mobile platform, so they can visit them when they are on the field, so they can compare what they see on the field with what
Sorry for interrupting you.
Assessment. I'm just in this last slide. Thank you.
Yes, thank you.
So, closing my presentation, I wanted only to tell you that whatever we develop in the ESAPE project, and as a coordinator of the Disaster Resilience Showcase of the ESAPE EuroGeo project, whatever we do and whatever we try to have on the continuous basis, the engagement of the end user community, the engagement of the users, farmer associations, as I mentioned before, but also insurance companies and civil protection authorities. But the involvement of the user is not just training or just presenting to the user the derived information. We have them as active co-designers. We develop the activity together with them, and we provide the information they want to have for the daily practices. By this, I would like to close, and I thank you very much for your kind attention, and I will be very happy to reply to any queries you may have on this ESAPE and specifically on the Disaster Resilience Showcase. Thank you very much for your attention.
Thank you, Dr. Kontoes, for this nice presentation about the use of Earth observation. Unfortunately, we should proceed with the last presentation of this session. And last, of course, but not least, and the presentation will be given by Professor Paolo Laz, a professor at the University of Grenoble Alpes and the University of Helsinki. Professor Paolo Laz, as interim Actris Science Chair, will present an overview about the European aerosol cloud and trace gases research infrastructure. So, Professor Laz,
yes,
share your screen.
Yes, I'm sharing my screen now. I hope you can see it, and it should be full screen.
Yes, it's great, and we can hear you also.
Okay, very good. So I will give a presentation on the Actris and the link between Actris and EMMENA. There is not much science in the presentation that I'm giving now. I guess some of the science has been presented in previous talk and in other talks that are scheduled in this meeting. Johannes, a few talks ago, has presented some of the activities that are indeed connected to the work that is under the Actris ecosystem. And I appreciated the fact that he used this term of ecosystem. And this is what I'm going to try to show with my presentation. It is to clearly explain what is the Actris ecosystem, what is the status of this Actris construction, and what we expect as a relationship between Actris and a partner, which is an important partner of Actris in Cyprus. And so this is what my presentation will be about. So to start with, I will just recall the main goals of Actris. Actris is a research infrastructure, so it's not a network of stations. The network in Actris is part of the research infrastructure. The network is a piece of the infrastructure where we provide the high quality data in an harmonized way with a series of observation stations that are located in Europe and beyond Europe. And so we are providing information on the evolution of the natural atmosphere, but we also have other kind of platforms that are the simulation chambers, or what we call the experimental platform, the mobile platforms that we can use more on a short-term basis, on an experiment basis we can deploy, and they operate with the same requirements as the observation platforms. So it is really to consider that Actris is not only this network of stations, but it's more than that, and it's platforms for atmospheric research that are connected to each other and that are working on a high quality basis that is agreed upon with the different partners of the research infrastructure. When we agree on techniques, we have to define what are the most appropriate measurement techniques for probing the atmosphere or being used inside simulation chambers. And we are really an ecosystem, research infrastructures where experts for the measurements are gathering together to make sure that the most appropriate measurement procedures are used, and they are used in an harmonized manner. Of course, we are talking about very highly advanced research platforms, and an essential point of Actris is really to make sure that everyone has access to the products of the research infrastructures in terms of data, and we're working for to make sure that all our data are accessible in a fair way. And we're also working towards having procedures to physically access the research platforms so that everyone in Europe can go to another country and do experiments with some kind of a support, either from the host country or from the European Commission to perform these experiments. We are also, as an infrastructure, providing a view of the atmospheric research in Europe and a tool for harmonizing measurements and investments in the different European countries, avoiding duplication of efforts, advising policy makers on issues that can be either local or made at the European scale, and also raising awareness of the public through different outreach actions. So it is really important to consider that that the network in Actris is only a piece of the infrastructure. So the general organization of Actris is very simple in a way. We have the provision of data from observation and experimentation facilities. We have the expertise in measurements and control of quality, and we have the curation of data and seamless access. When we are discussing about the access, always keep in mind that it is access to data, but it is also access to research platforms. And to do that, we have defined what a series of of elements, the national facilities, which are the research platforms, and the research platforms are operated based on investment that are made at the national level. We are defining the topical centers, which are our expertise and calibration centers, and these are in charge of controlling all the production of data in Actris. And we have the data center. And on every side of that, we have obviously space for users, because the research infrastructure is really something that is targeting the users, and it is the way each research infrastructures in Europe are evaluated. It is really the evaluation is really based on user satisfaction. And so we are very careful to make sure that national facilities are accessible to everyone. Topical centers are accessible to everyone who wants to make sure that they are running with the right procedures. They are running with instruments that are highly qualified. And then obviously the data center and the data and data products are open to everyone. For the topical centers, we have different kind of categories of topical centers, which are devoted to remote sensing or to in situ. Total, we have 6 different topical centers to include and control all the different Actris variables that we can produce. So this is a wide ecosystem with a number of European countries that are sharing this expertise, that are sharing the costs, and that have agreed recently on a way to organize the governance of this whole system. This is not simple. It is about who is paying for what is the role of the host country, the countries hosting the topical centers, what is the role of the host country hosting the data centers, what is the contribution from the basis for contributing for the financial contribution of all the different countries, what is the basis for the data policy, what is the basis for the access policy, etc. At the beginning of the year 2021, all the countries that are participating in Actris have agreed on those principles. And we are now in the process of signing this agreement in the different ministries. And we hope that this Actris will come into place as a legal organization, which will be based in Helsinki, Finland, a legal organization that will manage all this Actris ecosystem. Just for your information, these topical centers, the operation costs, the annual operation cost of the topical centers, the head office and the data center is approximately 16 million euro. And this obviously does not include the provision of data from observation and experimentation, which remains under the responsibility of the countries. And we have identified, based on country recommendation, a number of sites, of platforms that can provide either the monitoring of this of the natural atmosphere through the observational platforms. This is the graph that you have on the left. And you see that we have one platform that is proposed by Cyprus, together with a number of platforms in the same area proposed by Greece. And we have also on the other panel, on the right panel, a number of experimental platforms that can be either the atmospheric simulation chambers that you have in blue in that graph, or the mobile platforms that you have in red. And you see that in Cyprus, you have also provided a request to become an Actris national facility through proposing these mobile platforms, the drones, where you have developed a very strong expertise in Europe. You also see, because we are talking about a region, you also see that Greece has proposed also a number of experimental platforms, the simulation chamber and mobile instrumentation. And I think this is something of real interest for the whole region. And so I'm going to this, what was proposed by Cyprus in the Actris ecosystem as national facilities. Again, national facilities is the terminology for these observational platforms or the experimental platforms. Again, it is really a choice from the country to say we will be supporting these facilities in the long term, to say that we have the capacity to operate the facility because we are capable of maintaining high-level instrumentation with high-level personnel. This aspect with the personnel are fundamental in a research infrastructure, because more than the instrumentation, it is where the expertise lies, and it is really the long-term insurance for the research infrastructure. So on one side, I think it is clear that Actris in Cyprus is a node, an important node as a national facility. So you are delivering information that are compliant with the requirements in Actris. You are open for physical and remote and virtual access in the framework of Actris. And now the European Commission had put on the table, through the Atmo Access projects, of which you are a partner and a work package leader, you are involved in this Atmo Access by providing an access to these two facilities that you have identified as national facilities in Actris. Can you hear me? Can you hear me?
Yes, now
okay,
we can.
I have a problem with okay, I will continue my talk on another computer. I was really well organized to make sure that I sometimes have this kind of problem. So I'm sharing my screen again. I hope it's okay.
Okay.
Yeah, sorry for that. So you're producing, I don't know when I lost you, or you lost me rather. At this,
we cannot still see your screen, so
you cannot
can you
see
share
my
it
screen.
again?
So I'm sharing my screen again. And can you tell me when I lost you or you lost me? During at this
yes, at the end of this slide.
Okay,
yes.
So I'm just to continue on that. So you have the potential for producing high science and innovation through these national facilities. Also, I think another aspect which is of great interest to Actris is the fact that associated to research infrastructures, we are developing the concept of regional partner facility. A regional partner facility is a facility, a capacity to assist other regions in developing new capacities in relation to a research infrastructure. And I think this is really a way for opening new partnership in the research infrastructures. In a regional partner facility, you're contributing to training young researchers. Sorry for that. What's going on? To training young researchers. And basically you're contributing to developing a regional ecosystem with a smart specialization approach. In that case, perhaps the drones. And in that case, I think it is interesting to see that Cyprus, as you know, and you're a big actor in this context, Cyprus is strongly connected to issues related to climate change, air quality in the Middle East. And we know that this region of the world is under strong environmental pressures from both climatic and demographic stresses. We know, and this is the graph on the right, that we have a forecast of significant temperature increase in the region, coupled with strong changes in the water cycle. Drier the droughts and extreme events may become more frequent. And together with that, we have also a number of cities that are expanding. Cairo is one, and there is a presentation on that later on in this conference. I think this will be mixed with potential increase in the outbreaks of sarin dusts. And this is a very specific environment where we will need as a research community, really targeted experiments or targeted understanding of this very specific environment. And this is where I think the EMMENA and the Cyprus Institute have a very strong role to play. It could be something to develop an actress regional partner facilities in the Middle East. You already have an active role in this association of aerosol in the Middle East, aerosol scientists in the Middle East. And in a way, what we expect from actress is the fact that Cyprus Institute can be acting as an actress ambassador towards the research community in the region. I think you are well placed for, together with the scientific community, develop the synergies that are needed for the specific issues, scientific issues that are going to be developing in this region, related to climate change in particular, but also to air quality. You have the capacity to understand what are the needs for investments, for access, for training. When I say the need for investments, we can also think of specific places for developing, for example, simulation chambers that can really characterize the challenges that are ahead of us for the specific issues related to the region. And so it is important that we have ambassadors with actors to identify what are the funding opportunities for this kind of regional partnership facilities. And because it is a project in the European Union to make sure that also at the border of the Union, we have these developments, I think we have to go together through the work program of the European Commission, but not only, we also have to go through what can be offered at the level of DG Regio to find the right funding scheme to make sure that this regional partner facility in actress is implemented at some stage. And so basically this is what I wanted to say about this relationship between actress and the activities that you have in Cyprus. I mean, the participation of Cyprus in actress is really fundamental for the reasons that I explained, both the observation and the experimentation facilities. You have a good success with EMMENA, also financially, to invest in the kind of measurements. And you have a very unique expertise in drone-based atmospheric research. And there is many challenges in the region and the need for specific research programs in the East Mediterranean that would continue some of the work that was initiated several years ago. And so I think my message will be together with actress in the actress framework to develop this concept of actress ambassadors with communities in the Middle East, supporting the development of an actress regional facility, an actress regional partnership that will be really fundamental for actress as a global research infrastructure. And with that, I thank you very much, and I will put the acknowledgement slide, and sorry for the little problem I had with the presentation.
Thank you, Professor, for this nice overview about the research infrastructure for atmospheric research. And I'm sure that here in Cyprus, both Center of Excellence, also KRC from Cyprus Institute, and also Eratosthenis Center of Excellence in Limassol from Cyprus University of Technology are looking forward to contribute with the observational and also the mobile platforms to the ACTRIS. Hopefully, we will be ready next year for this aerosol and cloud ground-based remote sensing super site. So unfortunately, it's already 11. I don't know if there is any question for the speakers of this session. You can raise your hand if there is some question, or please use the Q&A to proceed at the end of the workshop when we have this time slot.
Thank you, Rodanthi. Thank you to all our speakers. Unfortunately, we won't be able to have a 15-minute break. We will proceed with the next session, General Atmospheric Research. And I want to call Dr. Johannes Buell, who will be the chair of this session.
Hello. So, Tomaida, you just said that we skip the break, or we do the break?
Yes, we need to skip the break to keep
we skip the break.
on
We
time.
continue now. Okay.
Yes, thank
Fine.
you.
Hello again from my side, everyone, and welcome to the next session about the general atmospheric research in the Eastern Mediterranean. Our first speaker, sorry, I have to announce one change in the agenda. There is the talk of Jamie Banks from Tropos is replaced by a talk from Moritz Harig, also from Tropos, and Moritz will talk about the Eastern Mediterranean as an ideal testbed to validate LiDAR retrievals with airborne in situ measurements in preparation of EarthCare mission. So this talk will replace the talk of Jamie Banks from 11:45 to 12. But now I'm really happy to announce you Professor Ali Ryder from the National Research Center of Egypt. Professor Ryder, I have heard your name a lot of times, and I'm really happy to now finally also hear a talk from you, because Professor Ryder was in contact with Tropos for organizing some measurement campaigns in Egypt, and I'm really looking forward to your talk. The stage is yours.
Hello?
Yes, we can hear you.
Yes, you can hear me now?
Yes.
Okay.
Yeah, we can hear you. Go ahead.
Okay. Hi, everybody.
Excuse me.
It is pleasure. Yes.
Can you also start your video?
I cannot use the video because the internet connection is very bad.
Okay, no problem then.
Yes.
Sorry, I'm sorry.
Sorry for this.
Yes,
okay.
Thank you.
Hi, everybody. It is a pleasure for me to introduce this presentation. It's the second virtual Excelsior workshop. Greater our presentation under title Air Pollution in Greater Cairo, Statistical Analysis for Monitoring Data. I am Ali Ryder, researcher at Theoretical Physics at National Research Center in Egypt. In the first, Greater Cairo divided into 3 governorates: Cairo, Giza, and Qalyubiyya. Cairo suffocates, let it breathe. By Arabic, القاهرة تختنق، دعوها تتنفس. 73 years ago, in 1948, an Egyptian magazine called المصور warned that Cairo will go to the following. This photo for Cairo, you can see the dust and the black carbon. This photo for a farmer burns rice straw at his field in Qalyubiyya, one governorate of Greater Cairo, in 2016, casing a black cloud of smoke that spreads across the Nile Valley, near the agricultural route that leads to Cairo. Yes. Do you hear me? Hello?
Yes, please go ahead.
This is the face Weber after a day walk around Cairo. Now we will go to the aim of our presentation. Our aim is analyzing some observed pollutants data as trying to understand the fact of air quality or air pollution in Greater Cairo in Egypt. We will use 4 types of pollutants: 2 particulate matter, PM10 and PM2.5, and 2 gases, NO2 and ozone. Sources of pollutants data. The Egyptian, we have 2 sources for the used data. The Egyptian Meteorological Authority, this data from 2000 up to 2004. The second source is the Egyptian Environmental Affairs Agency, and this data from 2010 up to 2015. In this map indicates the location of the 18 surface stations of WEWA, whose measurements are used in this presentation. The color code corresponds to the annual mean of the PM10 concentration: green for PM10 less than 120 microgram per cubic meter, the yellow for PM10 between 120 and 180 microgram per cubic meter, and red for PM10 concentration more than 190 microgram per cubic meter. This table describes the 18 station. The 18 station is arranged from the less polluted station, Abbasiyya, Nasser City, New Cairo, to more polluted station, Ma'asara, Maadi, Olali, Abu Zabal. This station were selected for being representative the full variety of environments, residential, roadside, industrial, traffic encountered in the area, and also for the completeness of their measurements. We will start with particulate matter. The yearly average of the daily PM10 concentration measured between 2010 and 2015 at the 18 ground stations of Greater Cairo have been calculated. Only the data of the years with at least 75 valid measurements are considered. This figure reports these individual values and their multi-year average for each of the 18 stations organized from the less polluted as previous in the previous table, Abbasiyya, Nasser City, and New Cairo, to the most polluted, Ma'asara, Maadi, Olali, and Abu Zabal. According to our analysis for own data, we will obtain some results. The first result, the average PM10 concentration for the whole Greater Cairo is 155 microgram per cubic meter, plus or minus 35 standard deviation. Second result, the multi-year average concentration doubles from Abbasiyya, which is less polluted, to Abu Zabal, which more polluted, and the inter-site variability is large. Third result, the range of concentrations measured at all stations is well above the 20 microgram per cubic meter, which is the air quality guide of the WHO, and also above 40 microgram per cubic meter, which is the legal yearly limit of the European Union, and also above the threshold of environmental law in Egypt, 75 microgram per cubic meter. At a finer temporal scale, the daily average concentrations measured from 2010 to 2014 exceed the 50 microgram per cubic meter, which is the warning threshold of WHO, more than 92% of the time at one of the least polluted stations, Nasser City, and 100% of the time at Mohandisin. This indicated in this table. By using the data in this table, it can easily be shown that the interannual variability of particulate matter concentration is less than 10% at the two sites, and this quite limited over a 5-year period from 2010 up to 2014. Figure 2 is the comparison of the temporal variations of particulate matter at Nasser City and Mohandisin. This figure shows that the largest PM10 concentrations are observed simultaneously at the two stations. This is consistent with the fact that the sharp concentration peaks are most of the time due to massive advection towards the city, either mineral dust raised by the wind in the surrounding desert, or so to lesser extent, carbonous aerosol produced by the burning of agricultural waste in Nile Delta. These advected particles contribute to worsening the air quality in the megacity as they are added to the background level aerosol. This background level reflects the human activities surrounding the measurement station, and this is why it differs from one site to another. We don't have except 3 years only data for PM 2.5. This data in form of a monthly average, so that we tried to drive the value of PM10, the value of PM 2.5 concentration from the concentration of PM10. The annual average of PM 2.5 concentrations were calculated from PM10, once using the ratio between them, and were found to increase from about 50 microgram per cubic meter in Abbasiyya to 110 microgram cubic in Abu Zabal. These two values differ by as much as factor 2, but they both are well above the 10 microgram per cubic meter, which is the air quality guide of WHO.
Excuse me, Dr. Weda, please try to wrap up. We have 2 minutes. We have only 2 minutes remaining. Thank you.
Okay. So 110 average, 110, but according, I have 15 minutes. Okay. When obtains an average 0.47 plus or minus 0.19 standard deviation. This ratio tends to smaller in spring, which is the peak of the dust season in Egypt. Now we will start to fall gases analysis. We have 15 stations monitoring the NO2 concentration. All of them exceed the 10 microgram per cubic meter recommendation of the health risk of air pollution in Europe. Only 4 stations exceed the less strict WHO yearly limit of 40 micrograms. The assessment of the actual exposure of the population to NO2 based on a few fixed monitors is made difficult by the extreme variability of the spatial and the temporal variability of its concentration. Notwithstanding this, the comparison with the particulate concentration at the 4 most polluted stations reveals that 3 of them, Ma'asara, Olili, and Abu Zabal, were already among those of with largest PM10. with such large particulate matter concentration observed everywhere, it can appear surprising that NO2 concentration remains under WHO limits at 11 of the 50 measurement sites. For ozone, the hourly data for ozone, we have it. From this data, we obtained the 8-hour sliding average, which is very important for health assessment. In spite of some inter-annual differences, this figure shows a typical temporal pattern of ozone with each winter minimum and the summer maximum is observed in the 4 years. Also, noteworthy, the range of variation between 20 and 140 microgram per cubic meter compared to the one of northern Italy. Discussion and the concluding remarks. In Greater Cairo, the sharpest peaks of particulate matter concentration are mostly due to the massive transport of mineral dust from the desert towards the city, with an annual mean of PM 2.5 concentration differing by at least a factor 2 from one sector of the city to other. The same problem occurs with NO2, whose concentration exceeds the WHO air quality guidelines in some particular sectors of the city strongly affected by traffic or industrial activity, but not in the others. The data available don't allow the assessment of the spatial variability of ozone because we have data for only one station, Abbasiyah. Thanks for your attention. Thank you.
Thank you very much for this talk, for this interesting talk. And we will have questions. If there are questions, we can discuss them in the questions, the Q&A session in the end of the conference. We will go on with a talk from Alexandra Chudnovsky from Tel Aviv University in Israel. She's one of the people in the Eastern Mediterranean who actually has a poly-XT and that maybe you saw my slides before, one of the 3 poly-XT in the Eastern Mediterranean. So I'm looking forward to your talk, Alexandra.
Thank you so much for your warm introduction, dear Johannes. So let's start. The title of my talk is Monitoring of Air Pollution in the Eastern Mediterranean using passive and active remote sensing. I'm going to show you a few examples using Haifa and Tel Aviv measurements, and also maybe some outlines for the future. So the facilities that we have, as you mentioned, we do have Tau Poly, built by Tropos. We also run measurements of PM 2.5, PM10 concentrations. We have additional meteorological instrumentations. We run drone facilities also, and we seek to collaborate. We want to collaborate. We also have Aeronet site next to a Poly site run by another lab run by Michael Segal-Rosenheimer, and also chemical measurements. So we do have pretty nice facilities in Israel. Let's start. I was very much fascinated by Haifa Technion collaboration run by Tropos. I visited a few times and I just wanted to have exactly the same fascinating measurements in Tel Aviv, which is very challenging area. We do have pollution that is mixed, always mixed with anthropogenic versus mineral dust. And it took time. You see a very nice picture of Dietrich, Birgit, Ronnie was always on the ground, so they built the instrument. Ronnie was the major force. And people that I listed, they participate in the paper, in the two joint publications, so one joint publication that we have, and of course we extend everything. And I expect for much more collaborators, much larger community that we work with Israeli data. So we have pretty nice constructions, and it was, we built the base and the home for Polytau, make the roof very much stronger. So now let's have a result. In the right, you see the Tau poly in the operation. So I'm going just to show you some highlights of two recent publications that we have this year. So one presents Haifa data, the impact of aerosol layering on aerosol optical depth measurements using satellite data. And we also have very nice collaborative paper with lab, hydrochemistry lab, air-water interaction. So the question here that we ask if it is possible to know if we just pump the water from the, pump the air from the atmosphere, convert to the water, and what measure chemical characteristics. And using this data, we can something to generate on the air quality in the urban area. So let's start. Yeah, that's the problem. What we have satellite data. Satellite data measure aerosol optical depths, and we have no idea, we do not have any knowledge about the vertical profiling. And also we also have a lack of measurements if the pattern, the spatial pattern variability, how trustable, how can we rely on this data set? In the upper, we see the air pollution along the seashore. So lower values on the green and larger values. So we do have more contribution of aerosols due to anthropogenic and dust, of course, sea salt, but we do have different patterns during different seasons and temporal patterns. So what we do usually, we just compare satellite data versus ground measured aerosol optical depths, which is the same parameter. So if I look generally on the data set that we had in Haifa, we were working with 5 months of data. So generally it fits quite well. However, we do have overestimation of satellite retrieved aerosol optical depth, and we have underestimation of AOD. So it's not completely, perfectly fix each other. And we study all these red points, that overestimation and underestimation and overestimation, using LiDAR data and also using environmental data additional. So we look at all different scenarios of simple layering versus complex layering conditions. And of course, we just compare and apply it to how all these different conditions, challenging conditions, look using satellite data, how the spatial profile looks like. So we built a huge data set. We not only satellite, we used high-split back trajectories. We used all available data parameters. We used ground monitoring data, Environmental Protection Agency with PM 2.5, etc., etc. And then, so we were working very closely with Albert. And okay, so first of all, sure, we can have a knowledge in Haifa area, the frequency distribution of basic layers. The first layer, heights, where a second layer starts and ends, a third layer starts and ends. And what we see so far, that it can stand the pollution layers up to 5 kilometers under certain conditions. And yes, the conditions in the Eastern Mediterranean are quite complex, at least frequency distribution that we have, at least we have 2 layers daily. Okay, maybe all these different scenarios are not included in satellite retrieval. And the most typical for Haifa area that we have using LIDAR ratio, that we have sea salt aerosols, the impact of sea breeze effect, and of course we do have dust, definitely. And the upper layer, generally we have dust as well, but we do have large contribution of anthropogenic pollution. And then we make different statistics and we look exactly. So first of all, we look at the correlation, satellite versus ground-based. And then we conditioned and different parameters, ground-based parameters, not only LIDAR-based, but also IRONET-based, like angstrom exponent, PM 2.5 concentrations, LIDAR ratio at the upper and lower layer. And we look very, very in detail and at all these challenging conditions that basically bias satellite retrieval, and then to build this large data set to be aware and to prevent. So let's have a look at the correlations, cluster analysis, where when we have good estimations, different layering. So what is the most challenging? Yes, the most challenging, of course, is when we have a cloud contaminated pixels, not surprisingly. But in addition, when we have marine at the lower layer and mostly upper anthropogenic. So this scenario presumably is not considered in satellite-based retrieval, and it is the most biased underestimation. It is overestimation for cloud-based, and it will be underestimated when we have a almost perfectly clean conditions. And with mixed anthropogenic, we are approximately fine, especially when it mixed with dust. We can estimate it nicely. And then we also compared, yes, lofted pollution, dust, and lofted pollution. We can also we are able to estimate precisely. It compares between satellite and ground-based. So we also wanted to have how LIDAR can be also make some parallel with a spatial profile of MODIS. And we just used this very simple statistics, simple variance. And in simple variance, we estimated if I have a large simple variance value. So remember, this is average standard deviation. So if I do have large variability, maybe I do have the contribution of local sources. If I do have large coefficient of variation, so I have more, maybe more clean conditions, but more local sources. So what we see so far, it is not so much complex layering conditions. With dust sources and dust contribution, I have much more complex layering, and then I am more biased. Okay, so a few more slides and we are almost going to the end. And the length of the dust layer, can be very thick and very lengthy. It extends up to 3 kilometers from 800 meters and even upper. So all these challenging dust storm conditions, when we have this dust is quite polluted, of course. And we were very eager to see the length of this depth layer for different conclusions. And as we also see, they are highly polluted. We have different sources by analyzing the back trajectory analysis, that it comes from numerous sources, numerous dust sources, as on the lower example. And the second example, few more slides, as I already introduced, we generated aerosols, converted it to water. That's Dora-Missar laboratory chemistry. And then we just wanted to conclude from this generated water on the air quality conditions. So LIDAR ratio, upper layer, we see dust storm events. Dust storm events in the lower, we do have high calcium concentrations, but even upper layer, we do have anthropogenic LIDAR ratio between 60 and 80 steradian. We still have calcium concentrations, which means that our dust is heavily polluted. And of course, heavy metal, copper, 4060 for the upper layer during anthropogenic high events. Wow, so this is exactly the same conclusion. It is anthropogenic pollution. It contains most particles. So it is always in Tel Aviv. It is either it come polluted already from different dust sources, and it is also polluted using indoor, outdoor urban pollution sources, which will have very, very heavy exposure to all traffic, and we do have industry, etc., etc. So in regions with vertically varying aerosol conditions, we have complex aerosol layering, which is typical case for the Eastern Mediterranean. And we must very detailed investigate all these cases and to know where we can rely on this special pattern when we cannot, because all these MODIS data sets are the input in all cloud change modeling, in radiative transfer modeling, and cloud precipitation evolution processes. And of course, in environmental health conditions, we want to know what is the source of aerosols. All epidemiological models fail to estimate precisely health conditions and health exposure because they only rely on PM2.5, which says nothing about pollution sources. So we can improve all our health exposure models. And that is extremely important data set. Where the pollution, where, what height. And we plan to extend our uncertainty studies for much more data set, of course. Until we will just continue run our measurements. And we are looking forward for, we see Eratosthenes Center of Excellence as potentially excellent collaborator to join our forces and to discover what happens in the Eastern Mediterranean, one of the most challenging areas on Earth. And yes, so that's my major conclusion. We need to join our scientific efforts in the frame of Excelsior data share expertise that lead to a comprehensive data analysis and to create better and healthier environments to live in. And acknowledgements, my students funded by Israel Science Foundations, and my dear collaborators that I expect that this list would be much, much larger. And we do have more partners that coming to us. And thank you so much for your attention. Thank you so much for your invitation. And I am very much honored to present my results and very much excited to be with you.
Thank you, Alexandra.
Thank you, Johannes, yes.
I very much liked your conclusions. And I think our steps towards more, we are always doing steps towards more collaboration, cooperation. I think this is an exciting way we are going. So next talk is from Dr. Kleanthis Nikolaidis from the Department of Meteorology, and he will ask the question if the meteorological infrastructure in the area of the Eastern Mediterranean is sufficient. Dr. Kleanthis.
Thank you very much. Am I loud and clear, and can you see my screen?
Yes, we can see the screen. You may go to full screen.
Yes, thank you.
Yes, perfect.
So, thank you very much. Thanks organizers for inviting the Department of Meteorology for a short talk on our very interesting area, not only on as concerns meteorology, but and for so many other reasons. A few words about the Department of Meteorology. It is in the organization structure of the Ministry of Agriculture, Rural Development and Environment, and it is the official authority of the government of Cyprus for the study of the climate and the weather of the area of Cyprus. And by the word study, we mean operational study and not academia study. We have a vast number of relevant data since 1900, which are available for academia study. Of course, we have to bear in mind the cost of retrieving and filtering this data. And of course, bear in mind the directive of the EU for free data. The Department of Meteorology and the Government of Cyprus is a member of the World Meteorological Organization, member of the European Organization ECOMET and EU MEDNET. ECOMET deals with data sourcing and formatting, and EU MEDNET deals with technical issues concerning the National Hydrometeorological Services of Europe. DOME is a certified organization by the National Supervisory Authority of Cyprus as an air navigation service provider. And of course, Cyprus Department of Meteorology is certified with an ISO 9001-2015. Land is very easy to be observed. We install stations, in our case, automatic stations, in Israel's case, automatic stations, and so on and so forth. A few years back, they were manned stations with staff 24 hours a day dealing with the weather. Nowadays, more modern technologies are involved in order to acquire data. Our network is accessible through the webpage of the department, and it provides near real-time data. I mean, a 10-minute-old data. A variety of data sets are supported by those stations. And of course, we can improve the surface density. There are areas with not well coverage. The newest automatic weather station installed at Mamari area, nearby Nicosia airport in the buffer zone. And it is there since 20 days now to support a runway for the Department of Forestry firefighters. And the area of responsibility, the area for which we provide services, is the wider area of Nicosia FIR, the Eastern Mediterranean Basin, and of course, the area of Cyprus, with a very, very difficult geomorphology, with high mountain, with deep valleys, deep and long valleys in most of Troodos Mountains area. Of course, the plain area, the main plain area between Pentadactylos and Troodos Mountains, and of course, the very, very warm surrounding Mediterranean Sea. But the area of the East Mediterranean is an area of great interest and development. There is intense development over the area of the East Mediterranean due to the hydrocarbons findings over the area, the Zohr or the Tamar or the other sources of hydrocarbons discovered recently. So in this case, let us see what is the connection between the meteorological stations of the area and the area as such. We can see that there are a lot of stations over the land, whereas over the sea area, there are absolutely no station monitoring the weather. And this limits the development because with the limited abilities of the observation network, other methods had to be employed. These drilling companies need certainty. They need a secure environment to operate. They need a good weather forecast. And in that case, conventional surface meteorological stations with or without personnel have limited capabilities. Their capabilities are very local. But if we consider the entire area, their capabilities is zero. The maritime area of the East Mediterranean is without observations, whereas observations can be employed by sea vessels operating in the area, by drifting or anchored buoys, from the drilling units as such, which are operating in the area. Of course, we have to find ways to overcome the very high cost of data transfer. This iridium communication is very high costly, it's a high costly communication method. And of course, the maintenance is a limiting factor for these three ways of acquiring data from the Eastern Mediterranean. The development of the exclusive economic zone, not only for Cyprus, but for Israel and Egypt and so on and so forth, needs a well-predicted environment. The meteorological environment is a part of the entire environment and is predicted or can be predicted. Factors such as state of sea and swell, wind speed, severe weather can limit the development in the exclusive economic zone of our countries. Due to the limited capabilities of surface, land, mainly sea observations, remote sensing technologies has to be employed to support development. And of course, we all know that remote sensing is the science for obtaining to know something about an object which is far away by observations from a distance with an aircraft or a satellite or a radar or so on and so forth. Satellite imagery of various spectra, either the visible or the infrared or dust like the MODIS or various other spectra are very essential, and it's a very, very good source of data sets for both land and oceans and can be employed in modeling. I draw your attention on the SANT of this severe dust event, a very popular image during this today workshop. It is the dust event which affected the area of the East Mediterranean, of our area, during September 15, from the 7th till the 12th of September. And it was caused due to a low pressure over the area of Syria, Jordania, and the high pressure northwards, which pushed into the area a huge amount of dust, which was especially over the southern part of Cyprus, a few thousand times greater than the first limit of wake up. Department of Meteorology of Cyprus has a radar network which is covering almost the area of the East Mediterranean. It is supporting two radars, one at Paphos area and the other one at Larnaca area, with a radius of 150 kilometers. These radars are X-band radars, and the data from DOM are appreciated from the IMS, the Israeli Meteorological Service, and with an MOU existing between the Department of Meteorology and IMS, we support them with radar data and they support us with Cosmo model outputs, a very convenient method for cooperation, collaboration between Cyprus and Israel. Of course, radar is not only for the land, the sea area, but also for the land area. We can see a severe hailstorm which affected a year ago, or a year and a month ago, during May the 5th, 2020, a severe hailstorm over the area of Nicosia as a result of huge thermal instability and dynamic causes from the higher atmosphere. But there are also other methods for acquiring data from areas which are not covered by land observing systems, like the advanced Categorometer, which is a very useful data set for the sea area of the Eastern Mediterranean. It comprises of the NOAA project METOP with 4 satellites at 25 kilometers, which are passing over the area and producing wind vectors of the wind at the sea surface by acquiring data from the state of sea. It is a very useful data set, but not covering the entire area, and of course, not covering throughout the time the entire area. There are sources of radio frequency transmitters and receivers. Transmitters can be installed at the shore, almost at the mean sea level height, and transmit waves towards the sea area, which are reflected back by the state of sea or this well, and they can give a good result, a good footprint of what the state of sea is at the time and the wind vector velocity and direction. We know that the receiving backscattered radiation is a footprint of the state of sea, which of course is a footprint of the wind and the sea surface. It is a very useful. It is a very useful tool, and I know that it is used. It is used in Israel for retrieving data for the state of sea over the Eastern Mediterranean. And of course, the denser the network of the radio frequencies antenna is, the better the resultant wind vectors at sea surface is. So remote sensing is the future. We have to bear in mind that the development and the related activities over the areas of or the area of the East Mediterranean, the weak coverage and distribution of the conventional meteorological stations, the pros and the nos of the weather modeling, the favored accuracy and frequency of nowcasted products, the so-called NWP for the area of the Eastern Mediterranean, the improvement of the efficiency and productivity of the development and related activities need the secured meteorological NWP environment. It is more than sure that remote sensing technology must be and can be applied to the area in order to cover the data, to obtain data from the sea area, from our exclusive economic zone, in order to improve development over the whole area. In that respect, the future belongs to remote sensing. I would like to thank you very much. Special thanks to the organizers, the Eratosthenis Center of Excellence, and of course, you, the audience, listening or paying attention to my talk. Thank you very much.
Thank you, Dr. Kleanthis Niklaidis. Thank you very much for your talk. That was a really enlightening overview about what you have there in the Eastern Mediterranean. It's an impressive array of instruments, and we are of course trying to extend this even a little bit more. Our next talk will be given by Dr. Moritz Harig from Tropos, and he will talk about the preparation of the EarthCare mission in the Eastern Mediterranean. Moritz, you can go ahead.
Can you see my screen now? The correct screen?
Yes, it's all right.
Okay. Hello, I'm Moritz Harig from Tropos. I'm here because Jamie Banks is not here, and I was scheduled originally for the conference, but then somehow left out, and now I'm in again. And today I want to speak about mainly the Airglow project, that is, and to test the LiDAR retrievals with airborne in situ measurements in the preparation of EarthCare mission. So airborne in situ and ground-based remote sensing have a long history, starting with comparison of extinction coefficients, going up to even more complicated things like CCN and INP in the past years. But comparing an aerosol size distribution is still a rather challenging task. So we have first attempts via inversion of the data, but I will show today some really nice comparisons, and for this a good aerosol typing is crucial. What do we have? We have our poly-XT from Tropos at Limassol in Cyprus during the SciCare campaign, but that Johannes already introduced. It was the whole lacrosse site at the Cyprus University of Technology. And we derive the vertical profiles of aerosol clouds. And within this campaign, there was the ALIVE campaign in April 2017, where the Falcon aircraft flew, sampling in situ data like size distributions and also like filter samples. The highlights of the ALIVE campaign will be presented later on by Bernadette Weinziel's talk, who was leading the campaign into the Falcon aircraft. And I will focus today more on the importance in the preparation of the Earth care algorithms, which are linking optical to microphysical properties. A short introduction to Earth care. I think Rob Koopman later on will also give you more insight. It's a satellite that will be launched in 2023 by ESA. And it has two active instruments, a LiDAR and a radar, and the passive, the imager and the radiation measurement. Maybe you can use a laser pointer, radiation measurement. And the idea is to construct the scene from LiDAR, radar, and imager, and then calculate the radiative flux at the top of atmosphere. And when you have a fourth instrument, the radiation instrument, compared to it, and see how all your assumptions work. And for this, we need a really good aerosol model to have for the aerosol scenes the correct values in. And so these algorithms can also be validated pre-launch, like in this, NASA calls it suborbital activities. I think there are other names for it. And the A-Care project, which I'm part of, is exactly doing this, taking the aerosol classification from Earth care, using the LiDAR station at Cyprus, at Limassol, and the airborne in situ measurements during the ALIVE campaign. Some short words about HETAG, the Earth care's aerosol classification model. And in this case, we come from the optical properties, from a measurement, type it, give it like a type, and each type, a microphysical property is prescribed, and with this, the radiative properties can be calculated. And it works our way around from the model as well. Here is the classification scheme based on the particle linear depolarization ratio on this axis and the LiDAR ratio on the other axis, where we have the dust with a high depolarization ratio, the smoke with a high LiDAR ratio, and marine with low LiDAR ratio and low depolarization ratio. And HETAG is consisting of 4 prescribed types that are shown here, like a small, strongly absorbing particle, small, less absorbing, large spherical, and large non-spherical particles. And these 4 types, when like these 4 components, and when an aerosol type is like constructed from all these 4 components. And in here are already these 11 cases that we compared during the ALIVE campaign. And we see we have really some wafer pure dust conditions, some more pollution-like, and even some mixtures in between where it's a bit more difficult to assess the correct mixture of the different types. And this is exactly why we went to Cyprus, to get this more complex mixtures, because if we want to have just dust, we go somewhere in the Sahara or so, or if we want to have something really marine, we go to a very remote place in the Atlantic. But really having these influences from all different kinds of aerosol types was the motivation to test our algorithms in the Eastern Mediterranean. And now away from the optical properties to the size distribution. First, we need to measure the optical properties, select the layers, then use the optimal estimation for typing, and to derive the mixture of the different components that I just explained to you. And with a prescribed mode radius and width of each component, we can then calculate the size distribution and scale it with the extinction coefficient. And here a first example is shown. A Saharan dust outbreak on the 20th of April 2017 over Limassol. This is like the huge dust layer from the PolyNet image. You find a lot of, like all the data are on the PolyNet webpage that I posted here. And The Falcon aircraft flew up and down to a sample at different heights, and we have chosen this part here between 2 and 6 kilometers more or less for the comparison. The LiDAR measurements at 355 at the Earth Sky wavelengths show a depolarization of 21% and a LiDAR ratio of 49. The typing gives then 92% of dust and 7% of marine. And with this, the optical properties in the optimal estimation could be calculated and compared. And as they compare within the uncertainties, this mixture is taken. It's just a short overview about the profiles that I have just presented, like the depolarization ratio shows the influence of sun dust, and even it was a strong event with the extinction up to 100 inverse megameters. But this is just short because now comes the interesting result. The first really into a comparison between the size distribution derived from the LiDAR. It's the black line for coarse mode and the fine mode. And the colored lines are taken from the Falcon aircraft at different height levels indicated here. And the black line from LiDAR is between 3 and 6 kilometers. And what we see, we lie here, especially for the coarse mode, like the center of the some micrometers, really with good within. For the largest particles that are missed by the LiDAR, and also for the small particles, like a fine mode, it's overestimated by the LiDAR. But in total, these dashed lines here are the effective radius that are at the end go into the aerosol model. The dashed line is from the LiDAR, it's the 1.7 micrometers and the uncertainty. And these are the Falcon-derived effective radii, that are slightly larger, but at least keeping in mind all these uncertainties and getting a size distribution out of the LiDAR measurements, it's a quite amazing agreement. And we have a second case with pollution from the north, from Turkey, at the 25th of April 2017. And we have like a layer here, mostly up to 2 kilometers over Limassol. And the Falcon flew in these morning hours of this day. And we see here the intensive LiDAR properties, a depolarization ratio of 7% and the LiDAR ratio around 50. So with the low depolarization indicates that it's not dust, but maybe some dust mixed in. And if we now see the size distribution, what we get, like from the LiDAR in black again, and in green, like in the center of the layer at 1.5 kilometers height from Falcon, we see that it agrees even better, especially the effective radius, which is really close to each other. And so these particles then go into the scattering model, like to calculate the radiation, giving the effective radius and also the refractive index. And yeah, the effective diameter already compares very well, and the refractive index we want to compare, but this is with a group from Darmstadt, and they are still looking at their probes to calculate, to measure the refractive index, that we have something to compare to. And coming to the conclusion, the general findings, we have 11 cases during the LIFE campaign on Cyprus during April 2017. 6 coarse modes dominated, mainly dust, and 5 fine modes dominated, the non-dust cases. And I have shown you just one example for each category. In generally, they agree quite well, but the LiDAR ratio also in general shows lower effective diameter due to more fine mode compared to the in situ measurements. And here I just want to point out that it's really important to have these different mixtures to really challenge the model and see if it can type and get the correct type. And so I think in these 11 cases, all these scenarios are included: Saharan dust, Middle Eastern dust, pollution from the north, marine. It's quite few cases only with polluted marine. It's more like dust that it was polluted. And yeah, and as an outlook, it was already a successful pre-launch validation of the Earth Care aerosol model in a complex aerosol scenario, but it's a starting point. 11 cases are not so much, and so it's really valuable to have more airborne or UAV in situ measurements compared to LiDAR measurements in the preparation for the Earth Care mission, but also for the polyphone method described in Memorial Advancement 2016. And so we have a high interest in further aerosol in situ observations above the LiDAR sites in Cyprus. And now, since last October, there is the poly-XT at Limassol. And so I hope we can get more in situ comparisons with this LiDAR site. Yeah, and I have to acknowledge that the Aircare project was funded by ESA. Yeah, this is the end. Thank you.
Thank you, Moritz. I like that you just mentioned the UAVs, because this perfectly leads to our next talk of Jean Siard from Cyprus Institute, who will talk about, let's say, the sister project to Excelsior, the EMMENA project. Moritz, I think you have to stop screen sharing.
I just did it.
Jean, please go ahead. Jean, we can't hear you. Still, we can't hear you.
Is it better?
Now we can hear you.
Yes, okay,
Perfect.
great. Sorry for that. So, do you see my screen as well?
Yes.
Okay, let's start. So, thank you very much, first of all, for the team of Diofantos and the Eratosthenes Center of Excellence to invite me. I'm happy to present, let's say, the complementary project that is dealing with atmospheric research in Cyprus, which is the Eastern Mediterranean Climate and Atmosphere Research Center, EMMENA, another center of excellence that is based at the Cyprus Institute in Nicosia. So briefly highlighting, but it has been already done all the morning, that the region here is a hotspot for desert dust, and with highest concentrations of PM from dust in the region of the Mediterranean, and with expected even increase of dust, especially from the Middle East region. It's also an emerging hotspot, not just for air pollution and dust, but also for greenhouse gas emissions, as you can imagine, for the region with oil and gas industry. And as of today, as of 2021, the Middle East is now emitting much more than the EU 27, with a strong increasing trend for CO2 emissions. Satellites observations in the region, because in situ observations are missing, highlighting again that it's a hotspot for CO2 with the OCO2 project, the OCO2 satellite from NASA, and the TROPOMI-ESA satellite data from NO2. So EMMENA is the, let's say, the complementary center of excellence of Eratosthenes, and it's aimed to document air pollution and climate change in the region and in Cyprus. It's an upgrade of the existing Atmosphere and Climate Division of the Cyprus Institute, has been funded at the same time as Eratosthenes, and involved 3 partners in Europe: the Max Planck Institute for Chemistry in Mainz, Germany, the Atomic Energy Commission in France, and the University of Helsinki. It aims to support departments of the Republic and academia from Cyprus, but also top research institutions of the region. So let's say the motto of EMMENA is to fill the gaps of observations for a better prediction of the impacts in order to provide national mitigation adaptation policies with innovative solutions. So our center is built around 3 departments: the Environmental Observation Department, the Environmental Prediction Department for modeling, and the Impact and Policy Department for impacts. Currently, our center is more than 100 research staff for 15 different nationalities. Our national network is established to generate and enhance research, innovation, and revenues, fulfilling our mission to support the government of Cyprus and different departments in their missions, but also academia, and in particular the Excelsior Center of Excellence, private stakeholders, and NGOs. We are also developing a regional network to enhance atmospheric observations in the region, with existing partnership all over the strategic countries of the Eastern and Middle East, in Lebanon, in Israel, in Egypt, in the United Arab Emirates, Kuwait, Saudi Arabia, and Qatar. We are developing air quality and dust forecasting in Cyprus and for the region. So this is a recent achievement with using WAFCAM model. And we are using in particular here for the simulation of weather data, the assimilated aeolus-wind fields in the framework of the ESA project with National Observatory of Athens. And we are ready now to launch this first operational air quality forecasting for Cyprus, in partnership with the Department of Labor Inspection. We have also regional activities in this domain. We are working with the Qatar Energy and Environment Research Institute in Doha for dust prediction, and also with the World Bank and the Ministry of Environment of Egypt for emissions in Egypt. We are leading the MENA Codex initiative. MENA Codex means the Middle East, North Africa, Coordinated Regional Climate Downscaling Experiment. This is sponsored by the World Climate Research Program. So a few results highlighting here the strong increase of projected temperature over the Mediterranean in the forthcoming decades. And here some simulations, projections of heat waves in the Middle East and North Africa, result also of our activities in the MENA Codex framework. We are developing the Cyprus Atmospheric Observatory. This is the ground-based component of ACTRIS for Cyprus, which completes the Limassol supersite of Eratosthenes, which is running remote sensing. So our in-situ ground-based station has been established in 2015 and been part of a lot of European and national programs. It's been part of also a lot of international networks, leveraging 1.7 million euro of budgets. Our strategy here is to have this atmospheric observatory in the top 5 EU super sites. And for that, we are putting in place a lot of complementary information, ground-based in collaboration with Eratosthenes, satellite assimilation, in situ, and UAVs, with our advanced partner of NCARE and also part of international networks. We are already part of a couple of them, and we are also aiming to be part of others like ICOS for the greenhouse gases or BSRN for the solar radiation. Example of collaboration we have initiated with the team of Diofantos Agimitis, and in particular with Rodin Mamori and Argyro Nisansi on air quality activities in Cyprus, leading to compliance, supporting 2 different departments of the Republic, Department of Environment and Department of Labor Inspection, to comply with EU environmental directives for the reporting of air pollutants and greenhouse gas emissions at national level, and also developing the air quality forecast model as shown just before. UAVs have been mentioned a couple of times this morning. We are happy to show it here with our private runway and private airspace granted permanently by the Department of Civil Aviation. And we are using ACTRIS to help us to provide the international and transnational access of this facility to European and international researchers. We are developing here UAV capacities which are accredited by the European Aviation Safety Agency. These are the drones that we are currently developing and flying, with a more recent development with multicopters and fixed wings. And we are developing all of this for the last 5-6 years with the capacity to fly with drones up to 4 kilometers and with a recently developed UAV balloon system up to the stratosphere. We are operating a large range of sensors for reactive gases, greenhouse gases, and aerosols in collaboration with academia and private companies. We are involved in the framework of the ESA validation of the Airglow satellite in a validation campaign in Cape Verde. And these are the underlined here in white, the 2 UAV systems we will deploy, and example of UAVs we are flying that will be flying for the validation of the satellite. So with different probes for measuring aerosol distribution of coarse particles. We are developing also mobile measurements of greenhouse gases, and we are launching air core profiling. This is a profile up to 34 kilometer altitude. So this is a picture of Cyprus, of Akrotiri and Limassol taken from the balloon at 34 kilometer. In fact, today we are launching another balloon. We have launched it 1 hour ago. It's currently flying above Cyprus at this altitude. We are also providing a 2D mapping of greenhouse gas emissions with regular weekly tour of the islands, and also 3D mapping with multicopters. In collaboration with the University of Bremen in Germany, we are part of the TCON network, the Total Carbon Column Observing Network, which provides long-term observation in the atmospheric column of greenhouse gases, comparison with air core, and validation of the OPO2, OPO3 satellites from NASA. And here example of measurements of 2019-2020 of CO2 showing the lack of a strong increase of CO2 and of last year due to the COVID, probably the COVID reduction of greenhouse gas emissions over the Northern Hemisphere. We are engaged in developing measurements in large cities, capital cities of the region. We have initiated before the COVID campaign with our colleagues, Dr. Ali Ryder, who presented just at the beginning of this session, a large campaign in Cairo. And we will be following up next winter in Doha in Qatar, and through collaboration with the New York University of Abu Dhabi and the Kuwait Institute for Science Research, campaign in Abu Dhabi and Kuwait in the next 2-3 years. Example of measurements, I wanted to show you here on the same scale, different concentrations you can get in Nicosia, Cyprus, and in Cairo in terms of black carbon and PM measurements. So you can see that the big difference you can get between 2 capital cities of the region in terms of air pollutants. And again, in collaboration with our Egyptian colleagues from NRC, University of Cairo, and French colleagues. Developing also an accredited air quality laboratory for Cyprus and the region that is accredited by the World Meteorological Organization, EMMENA, ACTRIS, and the International Atomic Energy Agency to provide support for European and Middle East colleagues. My last slides, we are also developing innovative products such as this lightweight OPC dust counter and low-cost air quality monitors, and we are transfer this type of development in Cyprus spin-off companies. With this, I would like to thank you for your attention and acknowledgement for the RSOSTEMES project. Thank you.
Thank you, Sean. I just got a message from Eleni Lully that we now have time for questions and answers for this session. So first, thank you very much, Jean, for your interesting talk. We are looking forward to build strong collaboration between the ECOE and the Cyprus Institute, also under the roof of ACTRIS. And I think those 2 institutions are very much complementary, and also these projects. I think this is a very good constellation. So to the listeners, do you have questions to the panelists of this session. If not, I would rather stop here and move discussions to the Q&A session at the end. So Eleni, if you are fine with it, Thomaida, I would conclude the sessions and we do the break now.
Thank you, Johannes. Yes, we can go ahead and start the break. We will keep strict times though, so we will have a bit of a longer break and come back at 1:30 for the next session. Thank you, everyone, and see you in an hour and 15 minutes.
See you.
μέρες